So today you are going to be filling out this worksheet. It's front and back that talks about microscopes. And you know, we got our friend the microscope here. I'll be telling you all of its different parts. But in the case of microscopes, before microscopes, we did not realize that there were unicellular organisms. We didn't know about bacteria, we didn't know about certain types of algae, protists, and we definitely didn't know about cells. But at some point in time, somebody invented a microscope. And you guys know that the root word micro means small, and scope means to see. So microscopes let us see really small things. And it allows us to see the cells. So we got two cells here, which we're going to start talking about. And just so you know, anytime you see a cell drawn like a circle, I want you to assume it's an animal cell. And anytime you see a cell drawn like a square, I want you to assume it's a plant cell. Now there are always exceptions to the rules, but we'll talk about those as we go. Now, in the case of a microscope, microscopes use lenses to allow us to see small things. So a lens would be something like a magnifying glass. It could be your eyeglasses, your contact lenses. But depending on how many lenses the microscope has, determines what category of microscope we have. So the first one here is what we call a simple light microscope. Simple light microscopes only have one lens. So your eyeglasses, which by definition lets you see smaller things. So eyeglasses are simple microscopes. A magnifying glass is a simple microscope. Your contact lenses, simple microscopes. You can even use a Ziploc baggie full of water as a simple microscope. But it does just have one lens, so it's not going to really magnify things a lot. And the energy source is light. We have to have light shining through in order for us to see. And so again, these do have very low magnification power. What we're going to use in our class, this guy here, is called a compound microscope. There's my thumb there, sorry about that. It has two lenses. It's got a lens up here, and it's got a lens down there. So compound light microscopes have two lenses. And so you look through both of those lenses at the exact same time. And so the energy source for these is going to be a light. You're going to plug this baby in and light's going to shine through so that you can see these really itsy bitsy small things. I keep getting my finger in the way. Okay. So compound microscopes do allow us to magnify things more because we're actually using two lenses at a time. Now, your sheet here says lens and your sheet here says objective. Okay. Well, if you flip over on the back, you've got your picture of a microscope. Right here, letter B on your microscope, I want you to label that is the eyepiece. Okay. Now, your page says lens. We're going to scratch out lens because this is a lens and this is a lens. So for letter B, I want you to write that that's the eyepiece. And in here, I want you to put the number 10. Okay. Because when you get your microscope, you're going to see that the microscope has a stamp on it. And that stamp will say 10. There's a lens in here, and that lens by itself magnifies things 10 times. So if you were to take that off, you could use it as a magnifying glass. Now you also have lenses down here. And these lenses, letter G, are these things called objectives. Now, when you look through this eyepiece, you're going to magnify things 10 times no matter what. But depending on which objective you choose, you're going to magnify it even more. Now, our microscopes have 4 objectives, and they're color-coded, and they're different lengths. So you can see red, yellow, blue, and white. Okay. Red is the objective you always start on. Okay. Red is short, so it magnifies things the least. So on your page, write red. Okay, so somewhere on your page, just put like red objective, put red equals 4x. So when you are on the red power, which we call low power, you're going to magnify things 40 times. So 10 from the lens and 4 from the objective. Okay, and that's what we call low power. And that's what you always start on. It's not going to magnify things a lot, but at least you can see the picture. And then when you want to change the power, you turn this thing right here. Okay. This is what we call the nose piece, and the nose piece turns, okay, so you can change the power. So whichever one is hanging down is the one that we're going to use. So you can see here we have a yellow ring. That's what we call medium power. And that objective on your page, right, yellow, that objective magnifies things 10 times. And when you look at it, you can see that there's a stamp on there. So like there's a 4. Okay. Well, the yellow one is stamped 10. So when you're on what we call medium power, you're magnifying things 100 times because you're magnifying things 10 times here times the 10 things that you're magnifying it here. So medium power is yellow, and that magnifies things 100 times. And then when you flip to what we call blue power is high power. So somewhere on your sheet, write blue equals 40. This thing alone will magnify things 40 times. So when you're on blue power, you're actually magnifying things 400 times. So on your sheet here, I want you to change lens to eyepiece. Okay. No matter what, the eyepiece always magnifies things 10 times. Okay. And so depending on what objective you have, you're going to multiply those together. So when you're on low power, which is red, you're magnifying things 40 times. When you're on medium power, which is yellow, this would be 10, so you're magnifying things 100 times. And if you're on high power, which is 40, you're magnifying things 400 times. Now we do have an even higher power on our microscopes, which is the white objective. We never use the white objective. Okay. We do not have the slides that allow us to focus up that high. So you'll just use low, medium, and high power, red, yellow, and blue. Now, this microscope that I've been showing you can magnify things up to about 5,000 times. But sometimes, if you look at this type of microscope, you're not really going to be able to see inside. You're not going to be able to see all the different parts of the cell. Even though it magnifies the cells are still so small, you can't really see the parts really well. So if you want to get an even higher magnification, we're going to use an electron microscope. Electron microscopes can magnify things up to 100,000 times. And the way that they do that, up here, the energy source is light. I basically plug it in, I shine a light on it so you can see it. These guys look nothing like the microscope you're used to. Okay. These guys shoot electron beams. Remember, electron beams have a negative charge. And so they're going to shoot radiation, kinda, at whatever it is that you want to look at in order to form a picture. So, depending on for the type of cell that you have, I just lost everything here. Okay. Depending on the microscope, so we've got our compound microscope, which lets us see all these inside parts. What we're looking at here is actually a root. Okay. We're not going to use a dissecting microscope. Okay. You can have what we call electron microscopes. And electron microscopes use a beam of electrons. Okay. And depending on how you shoot the electrons, you have two types. Now on your page you'll see SEM and you'll see TEM. SEM stands for scanning electron microscope, and TEM stands for transmission electron microscope. A scanning electron microscope acts just like a sonar or a radar. It basically shoots electrons and allows the electrons to bounce back. So the electrons don't go through the sample, they just bounce off. And so that allows us to see a picture of the surface. So you can think of scanning and surface being together. Transmission electron microscopes will actually shoot the radiation through the specimen. So you can actually see things that are inside. So you're going to get really nice, clean pictures. Now, with your microscopes, so you can see here, this one here was done by a scanning electron microscope. So you can see, you just see the surface, and you can see how nice and clear and how blown up. This is a hair follicle. And these are cells. These are done by transmission electron microscopes. So you get really nice pictures, better pictures. So they actually look like photographs than what you see by just using a regular microscope. So in the case of the microscope, just a little rule of thumb. Okay, when you're carrying the microscope, always carry it with two hands. Okay? You hold it like a baby. These microscopes are real expensive. These microscopes cost about $1,500. So you don't want to drop it. Okay? Sometimes it'll look fuzzy. I do have lens paper, and so when we do the lab, I'll show you how to use that. And do not force the knobs. There are certain knobs on this microscope, and I'm going to tell you what those knobs do. Okay. And then store it covered. When you get back to the back, you'll see that our microscopes have cloth or plastic on them. And that's basically to keep the dust out of the moving parts. Now, so in the case of the microscope, okay, like we said, we've already labeled, you've got this on the back, and this diagram has more parts than what's labeled on your page. But we've already labeled letter B. Letter B is what's called the eyepiece. And like I said, the eyepiece has a lens in it by itself that allows us to magnify things 10 times. Okay. Now you don't have this line on your drawing, but please add it. It's called the body tube. You also don't have this line on your drawing. Okay. But on your drawing, it would be about right here. Okay. So add that. It's called the nose piece. Okay. The nose piece is what you're going to turn in order to change your objectives. And so when you're moving it, you need to make sure it clicks into place. Okay. You'll feel it click, and that way you know that the light can shine straight up the microscope. Okay. It's what we call the revolving nose piece. And the objectives are attached to that. Okay. So we've talked about the objectives. Okay. The objectives you can see in this picture, they do have different lengths. Okay. Those are the lenses that we use. And we label that as letter G on your page. We also have the arm. The arm is letter H on your page. You're not going to pick up the microscope by the arm and just hold it. You'll hold one hand on the arm and you'll rest, this is called the base, on your other arm. So you're going to cradle it like a baby. You then have this thing, it's letter E on your page, called the stage. On our microscopes, this is the stage. And the stage is where you're going to slide your slide. So right here you can see that's where the light's going to come through. And so you'll use the objectives to magnify whatever it is. And the stage can move up and down, which we're going to talk about here in just a second. And that's letter E on your page. You then have these things called the stage clips. Now the stage clips aren't on your, they drew them on your picture, but it wasn't labeled. But these are your stage clips here. And the stage clips are used to hold your slides in place. Now, you have two knobs on your microscope. The big knob, which is letter D on your page, is called the coarse focus knob. Okay. That's this knob right here. Okay. The coarse focus knob allows you to find what it is you're looking for. Okay. It's not going to give you a clear picture, but what the coarse focus knob does is it moves the stage up and down. And that allows you to find something in the view. Now, just because you put a slide on there doesn't mean you're automatically going to see something. You might have to move the slide around, but you use your coarse focus to move the stage. And just so you'll know, always put the stage to its lowest point, put the slide on there, and then you slowly move the stage up. Now, you only use the stage when you're on red, because red is short. And even though the stage is all the way up, you can see there's still a lot of space between that. Once you flip objectives, never, ever, ever touch this knob again, because you can break the lens. Because notice when you're on high power, whoop, there is no space. I can't even get my fingernail underneath there. So you don't want to change the stage when you're on a higher power. So you only use the big knob when you're on low power. And like I said, the big knob moves the stage up and down. And so right now you're like, but there's still a lot of space between there. Well, there's nothing here right now. But remember, you're going to have a slide there, which is a piece of glass. And so that glass is going to take up that space. And you can crack that glass and you can crack that slide. You also have this small knob right here. And the small knob is what letter A is on your diagram. It's called the fine focus. Now, you can use that one anytime you want to. If you were to move the fine focus, you wouldn't even see anything happening to the microscope. The fine focus actually lets you focus. The coarse focus is just going to help you find something. It's probably still going to be blurry. The fine focus, though, is going to be what gets rid of that blurry. It makes it fine. It actually clarifies. It actually cleans up the picture. Now, letter C on your page, oops, there's the base. Okay? The base isn't labeled on your page, but anyway. Okay? Now, you have something called the diaphragm. The diaphragm is letter F on your page. Now, the diaphragm allows you to adjust the light. On our microscopes, we have this little lever right here. Oh, they're going to make an announcement. They're looking for somebody.
If you are still in the building, can you come to the main office? Rajon Dunn and Trayvon Dunn. If you guys are still in the building, will you please come to the main office? Thank you.
I can't pause this because if I pause it, it starts all over again. So you've got this little lever right here. And this little lever is called the diaphragm. It's also called the iris. Now the iris is the colored portion of your eye. And you know your iris can get smaller and your iris can get bigger. Well, what that does is it regulates how much light. So if you could see this when you move the iris back and forth, this opens and closes. So it allows you to dim the light. So sometimes if you get the microscope and it's turned on and you can't see anything, move that lever because it might have accidentally got closed. And then we have our light source. And the light source, obviously, for us is going to be a light bulb. I wanted to put this on here because you will see the term scanning sometimes. But like I mentioned, you're going to put the slide on the microscope. You're going to hold it in place with the stage clips. And then you're going to start on red, which is the shortest. We also call it scanning or low power. Because all you're doing is you're just scanning it. You're not really going to see anything. And you'll look into the eyepiece, and then you'll use the coarse focus. And then once you flip over to high power, again, you're going to start on low power, which is red. Then you'll click it to whatever you want to use next, and then you'll never use the coarse focus knob again, ever. Okay. You're going to use the fine focus knob. And it will allow you to see all these different things on your slide. So, you've got yourself a little quiz here. I think you and your partners can figure it out.